I'm Mike.
And I'm Brendan, and this is Mythbusters.
Today we've given ourselves a disability. A disability that many people suffer for, and many people suffer to in this country. We've taken away one of our eyes. Each year, many people lose one eye in their body, left or right, to a disease or some few unconventional circumstances. Today, that's what we're testing.
Our hypothesis is really covering one eye, have the ability to catch a ball. As a group of me and Ike, buttermilk milk and eggs, we think yes.
The steal in the three. 88-71.
We're going to be using three tools: the football, the basketball, and the tennis ball. And myself.
Time to collect some data.
Mode. So, set.
Time for tennis.
How did you catch that?
I got it.
You didn't catch it. No, you did it. It bounced.
Don't.
My turn. It's basketball time.
Time for basketball.
So clean that she could that must have been harassing me in the mind. This girl is fine. I done came to the club out 50 times. Can I play with your line? The club wanna say I need to calm down. Security guard gonna swing me now. Play a and I'm mug, threaten me now.
She getting drunk in the club, I mean she work. And then I like to see the female. I put a pop your thing like this, cause you ain't twinning this. Lil' John and the East Side boys with me, and we all like to see.
Our hypothesis concludes that having one eye does affect your ability to catch a ball.
Here's why. Outside of about 20 feet, The couple of inches between your eyes doesn't make any substantial difference, and so engaging distances outside of 20 feet, it doesn't matter if you have one eye or two. The guy with one eye sees the world outside of 20 feet the same as the guy with two eyes. It only really matters for stuff closer in, and the closer in, the more significant the difference.
The eye uses three methods to determine vision: the size a known object has on the retina, moving parallax, and stereo vision.
The size of a known object has on your retina. If you have knowledge of the size of an object from previous experiences, then your brain can gauge the distance based on the size of the object of the retina. Smaller objects are more difficult to gauge than larger objects. You can take example the tennis ball we used.
Moving parallax. When you move your head side to side, objects that are close to you move rapidly across the room. However, objects that are very far from you move very little. In this way, your brain can tell roughly how far something is from you. And when you take one eye away, your estimation of how far the ball is coming to you suffers greatly.
Stereo vision. Each eye receives a different image of an object on its retina because each eye is about 2 inches apart. This is especially true when an object is closer to your eyes. This is less useful when objects are far away because the image on the retina becomes more identical the farther they are from your eyes. This greatly affects hand-eye coordination when trying to catch a ball with one eye open and the ball is moving closer and closer towards you. We think that this myth is confirmed, but only for small objects that are hard to catch even with both eyes, like a tennis ball. Larger objects like basketball are easier to catch and prove no difficulty catching. For medium-sized objects like the football, hand-eye coordination and skill are needed to catch it. The errors we conducted during our research were determining certain distances. We often threw the objects either too close or too far. If we were to do this again, we would set a standard distance from the thrower and the catcher to get accurate results. Also, for the tennis throwing sequence, the one who held the camera had to also throw the ball, making it hard to record and give an accurate throw. Next time, there would be a third person to help throw the objects to the catcher.